Good day, everybody. How are you all doing? Hope you're doing great today. Today, we are going to talk about conditional probability. So, before I get started, as I always do, I tell you that I have made a lot of these videos explaining difficult topics in statistics. So, when you get a chance, please subscribe to my channel and you will get access to a lot of these videos where I try to explain the concepts as well as I work out problems. So please subscribe to my channel, and my request is please do not quit right away because I will give you some important tip at the end of this program, definitely. So let's get started without further ado. So, like I said, we are going to talk about conditional probability. There's a condition in this case. As you will see, condition means some event has to happen. Some event has to happen beforehand in this case. What is a good example of that? Suppose the probability that a male person is more than 6 feet tall is say 0.52, 52% chance that a male person selected at random is taller than 6 feet. Now think of a situation where the man, is playing basketball, professional basketball. In that case, knowing that the person is a member of a professional basketball team, the probability that the person is taller than 6 feet will be much higher than the standard probability of a man being taller than 6 feet. Why? As you can appreciate, people who play basketball tend to be taller than the average. You all know they will reach the basket easily, they will be able to shoot easily. I mean, good chance of the ball going to the basket if the person is taller. So the condition in this case is the person plays in a professional basketball team. Therefore, the probability that the person is taller than 6 feet will be much higher with that imposed condition that he is a member of a professional basketball team. So the event that has happened first is that the person is a member of a professional basketball team. What is the other event? That the person is taller than 6 feet. So as you can see, there's a condition imposed that has happened first, member of the basketball team, and then another event we are looking at, the person taller than 6 feet. Okay. So here they explain with a different example. Define the following events. E, the event that individual has the disease, some kind of disease they're looking at. F is the event that the individual's diagnostic test is positive. So E is the event person has the disease. F is the event that the individual's diagnostic test for the disease is positive. So here is the conditional probability of E given F. That vertical line is read as given F has occurred already. This is a conditional probability. F is the event that has happened first. The person's diagnostic test is positive. E is the event that the person has the disease. PE given, again the vertical line is given. F is used to denote the probability of the event. E, given the event F is known to have occurred. This is represented symbolically as P. Event E is the person has the disease, given vertical line, positive test result, or PE given F. This probability is called conditional probability. Why? Because the condition, the event that has happened first, the person's diagnostic test is positive, And then the event we are looking for that the person has the disease. So here is an example. They are looking at people that have been searched when they were stopped at traffic signs. And they divided the drivers into their racial classes. Okay, Asian, Black, Latinx, White, other. These are in the vertical columns. And then there is a property on the horizontal rows. The rows are the horizontal lines, searched and non-searched. So the categories of races are Asian, Black, Latinx, White, Other, and Total. White, Other, and then you have the total. Total means you add all the numbers in the search category, and there is another category of not searched. Okay. What is your total sample size? Is 36,716 people that participated in this study. They're divided into racial category. Also, they're divided into other categories, whether they were searched by police or not searched by police. Okay. So, if you look at the white category, you find that there are 800 white drivers in the first row who have been searched. But look at the not searched white category is much higher, more than 10 times higher, 9,827. This is okay. This is the way to look at the data. Okay. So let's delve into how to find the probability that the driver is Latinx. So you look at the total of the Latinx column, which is divided into two categories, searched and non-searched, but the total is 8,404 out of a total number of people who participated in this study is 36,716. So probability of Latinx will be 8,404 divided by 36,716. Okay. And so forth. Okay. Now we look at the probability of the search category. Look at the data in search. Total number of people who have been searched. Sum of the first row or horizontal row of data is 4,998 divided by, remember we always divide by the sample size, in this case is 36,716. As you can see, the majority of the people who participated in this study were not searched, and that probability will be 31,718 divided by 36,716. Okay, so search category is only 14, which tells us that 1 minus 0.14 is 0.86, the probability that the person is not searched. Not searched, remember, using the complement rule, will be 1 minus probability of search, or 1 minus 0.14, which is 0.86. Here we applied the complement rule, probability of complement event. Okay, now let's look at some conditional probability. Probability of search given black. Think of it as this way. How do they come up with these numbers? Out of the total black searched, how many were, so out of the total black who participated in the study actually, how many were searched? Out of the total number of blacks who participated in this study, how many were searched? Total of black column is 13,856. They participated in this study. And out of them, how many were searched? Is 2,822. So it will be probability of searched given black, searched given black is 20%. Out of the total number of blacks, 13,856 who participated in the study, out of them 2,882 were searched. Why is this important? Now let's look at the probability of just the search category. Search is 4,998 divided by 36,000. That is all categories of people, all races. 4,998 divided by 36,716, and that is 0.14. That means only 14% of all classes of drivers, of all races of drivers are searched. But when you look specifically at black, what is the probability that the person is searched with the condition that he or she is black? And that is will be, out of the total number of blacks, 13,856, how many were searched? Were 2,882. As you can see, that probability, conditional probability 0.2, is higher than the probability of all races being searched. So you get the point that your racial profile makes a difference. If you are a black, there is a higher probability than the general average to get searched. So this type of situation is called a conditional probability. The conditional condition over here is the event that the person is black who participated in the study. And what is the other event? That the person, given the person is black, he or she is searched. Okay? And that probability is higher than the general probability of just getting searched. So there is a racial profiling going on. Okay. In the last paragraph, notice that the unconditional probability of search 0.14 is not equal to the conditional probability of search given black is 0.2. Again, suggesting racial disparities in terms of which drivers are searched. So you get the general idea. If I have to get a conditional probability, then I have to think about the total of the category or the condition that has happened first, in this case black, that goes in the denominator. The total count of that category or that event goes in the denominator. Out of this total category of black, how many have been searched? So this is the way the conditional probability is defined. Probability of search given the person is black, out of the total of black, which goes in the denominator in the bottom of that fraction, how many are searched goes in the numerator. That is your conditional probability. So basically what is happening, out of the total of black, so probability of here E given F, so probability of F is in the denominator, or and in the numerator what is happening, where they intersect, black and searched is in the numerator. Or you can think of, out of the F, if F is black, condition is black, out of the total of black in the denominator, how many are in the other event which is searched, which is in the numerator. So the numerator is the small number, the denominator is the large number. Gives you a fraction or a decimal, which is the conditional probability. Okay. So data traffic done in Sacramento and whether or not the Navigator website transferred also gives the data. Here they're looking at whether there are contrabands found and or contrabands not found. These are in the columns. In the rows horizontally you have the classes: black, Latinx, white. Okay. So what is the conditional? Let's look at B is the driver was black, C contraband was found, L driver stopped was Latinx, W driver stopped was white. So we found that we want to find out what is the probability that the contraband good was found. So the total of contraband good was 1,176 cases divided by the sample size of 4,758, and it's 0.25. Okay. And let's look at the probability of black. Total of black is 2,822. That particular row of black divided by sample size 4,758. Okay. Similarly for Latino and for white. Okay. Now let's look at the conditional probability. The person's being investigated is black. That is the first event that has happened first, out of which how many had contraband good. Okay, so black is the condition, contraband good. So look at the black. Total of black is 2,822. Out of them, how many had contraband good? 663. So the conditional probability of contraband found, PC, given the person was black, is 663 in the numerator divided by 2822, okay, which is 0.24. And then look at just contraband on the average is 0.25, so they're not too bad. But then look at contraband given the person was Latino. So contraband given the person was Latino is 286 out of 1136. Okay. And that is 0.25. That's also about the average. Okay. Probability of finding contraband search black or less than a little bit. Okay, probability of finding contraband in such a wide area is greater. So let's look at contraband given the person was white. Contraband given the person was white. Total is 800. Out of them, 227 had contraband goods. So 227 divided by 800. 227 divided by 800 is 0.29. That is generally higher than just the average probability of finding contraband goods is only 0.25 as you see in this slide. So contraband given white is higher, okay, probability. So you take the total of white on the numerator. Out of those total of white, how many had contraband goods? That probability is 0.29, which is greater than general probability of contraband goods. Okay. We will not go into all this crazy things. Okay. So bottom line is this definition of conditional probability. How do you find the conditional probability? You think of an event F in this case, which happened first. Remember, person's diagnostic test is positive, and then E has happened. E is the person really has the disease. So first, the test has come out positive result. Then does the person really have the disease? That is E. So this is probability of E given F. F has happened first. If this person's diagnostic test is positive, E is the event that the person has the disease. So E given F is out of the total of the tests which are positive, how many really have the disease? Okay, that goes in the numerator. In the denominator is a larger number. How many are total uh, positive test results? F. Total of F in the denominator. In the numerator, in the top is a smaller number, which is out of the total of F, how many really have the disease? That is E. That is how you find out. And by the way, these tables that you saw, these tables are called contingency table. Why it is called contingency? Because there are several properties. Here, for example, the races along the column, and in the rows you have whether they are searched or not searched. Okay. So for example, total of searched is 4,998. So probability of searched is 4,998 divided by 36,716. And the opposite will be event, complement will event probability will be probability of not searched, which is 1 minus probability of searched. We also looked at conditional probability. What is the probability that the person is searched given the person is black? So we look at the total first row of searched is 4,998. That is the large number goes in the denominator. Out of them, how many are black? 2,822. Okay. So that's how we find out the conditional probability that the person is black, probability person is black, given the person is searched. So searched has happened first. Bottom line to remember here, what is given, the total of that event, it goes in the denominator, and the characteristic of the other event that we are looking for goes in the numerator. The total of that event goes in the numerator. And the given condition goes in the denominator. Usually, that is, the denominator number is higher than the numerator number. So, I will stop here today. You can also use this definition of conditional probability. Let's see. This is the definition. In the numerator, we have the intersection part where E and F intersect. Okay, E and F intersect. For example, let's look at what is the probability that the person is black given the person is searched. Okay, so again, the first, the condition goes in the denominator, which is searched. That probability will be 4,998 divided by 36,760. The entire thing goes in the denominator. And then we look at the intersection of searched and black probability. It will be 2,822 divided by sample size of 36,760. So using this definition, this is the definition that you are using. And the numerator is the intersection where black over here and searched intersect. That number divided by the total sample size goes in the numerator. In the denominator, the conditional probability, which is searched, total of searched divided by the sample size. That is one way you can do it. The other way, the easy way in this kind to that you can do in this type of table is to look at the total of searched, which is 4,998. Out of them, how many are black? That is the intersection part. Remember, searched is a circle, out of which how many are black? The intersection of black and searched. If you think of two circles, black is one circle, searched is another circle. Where they intersect is black and searched. That goes in the numerator divided by total of searched. That is what I was using to find. In any event, using either the way I looked at it, that is out of the total circle of search, what was part was black, that small part goes in the numerator and the total of the searched goes in the denominator. You can use that kind of information, or you can use this definition to find out the conditional probability. But this is very important because it happens in real life. Like I explained to you, what is the probability that a male person is taller than 6 feet? Okay, and what is the probability that the male person is taller than 6 feet given the person is is a basketball player? That probability will be much higher because the condition is the person is a basketball player, and usually basketball players are much taller than the average person. Okay, so I'll stop here today. Any question, comment, write me a note. I'll get back to you as soon as possible. If you like this video, share with your friends. If you like this video, please give me a thumbs up. I really appreciate that. And let me know, where are you watching my video from? What else you want me to cover? Please write me a line. I appreciate that. And share this video with your friends, and please do not forget to subscribe to my channel by hitting the red subscribe button. Okay, and please do not forget to watch me tomorrow when I will be back with another interesting video. Thanks for taking the time to watch my video. Take care. Have a nice day. See you. Have a great day. See you tomorrow.